We've already had a look at the three different types of gate that we have, which are NOT gates, AND gates, and OR gates. And we're going to look at how these can be combined together and how we can make truth tables beyond just the simple three gates. So let's start off going fairly simple. Let's have an input of A and an input of B. And these two inputs are going to lead to an AND gate. And then from this gate, we're going to lead to a NOT gate, like that. And then our output will be from here. So in this case, we can do a truth table, and I'm going to put in a letter C here just to help me out. So that's what the output from the beginning is. So I'm going to have input A, and I'm going to have input B, and I'm going to have C, which I've created, and I'm going to have my output. And so into A, I can place a 1, or I can have a 1 on B, and I can have a 1 and a 0, or I can have a 0 and a 1, or a 0 and a 0. If I get 1 and 1 in A and B, then C is going to give me a 1. At this position here, I'll have a 1. Any of the others, because I need both of them to be true, all of the others will be zeros. Now at this point, from C to the output, I'm inverting it or making it the opposite. So if I have a 1 to get to the output, it's going to be a 0. And all of these zeros are going to become 1s. So if my input A and B is 1 and 1, then I'm going to end up with 0, and the opposite for all of the others. So here we have the truth table for this logic diagram. So this time I'm going to try something a little bit harder, and so I'm going to take an input of A, and I'm going to take an input of B, and I'm going to put these into an OR gate. And so that'll be the output of A or B. And I'm also going to take an input of a C, and I'm then going to invert that, make it the opposite with a NOT gate. And then I'm going to take both of those and put them into an AND gate. So I've got NOT C and A or B. And I'll write that out for you. So it's A or B and NOT C. So my truth table will be A as my input and B as my input, and then I'm going to have A or B. So that will be here what the result of A or B is. I'm also going to have my input of C, and I'm going to have NOT C. And then I'm going to have over here the result, which is my output, which is A or B and NOT C. So let's look at what happens. If I put in a 1 and a 1, A or B will be 1. 1 and a 0 will be 1. 0 and 1 will be 1. And 0 will be 0. Then in C, I can then have another 4. And so let's just go with C being a 1. NOT C will therefore be zeros. And so A or B and NOT C. So I'm looking for A or B, which is this column, and NOT C, which is this column. So in this case, because all of these are zeros, these ones here, it doesn't matter what they are, because I need them to both be a 1. So all of them will come out with a 0. Now I've only done half of it here because I've said that C are all 1s and therefore NOT C are all zeros. So in this case, with C being 1, all of these will end up being a 0. However, if I was to change C and do the other half of them, so let's do that now. So let's just erase out these and so this is going to be different, and this is going to be different. So now in this case, I'm going to use my C's being zeros, and so my not C's are going to be ones. So my A or B and not C, so A or B and not C. The top one is a 1 and a 1, so that's a 1, and then I get a 1 and a 1, which is a 1, a 1 and a 1, which is a 1, and a 0 and a 1, which is a 0. And so there, although I've had to do it in 2 different versions, there I have done the truth table, which contains 8 different possibilities for this diagram here.